And if you want to track this analogy back to what we did before, the average velocity would kind of be the same idea as like the slope of our secant line, right? Average velocities in some sense are analogous to like secant lines, whereas the instantaneous velocity really has more to do like the slope of a tangent line. Let's see here. So an example, simple example, might be this. Suppose you've got y is equal to, I don't know, 10 minus 3t. All right. You could calculate the velocity of this thing. All right. I guess I should have put an x there. I've been using x for everything else. Let me not be weird. X. There you go. What's the velocity here? So basically, we take, let's find velocity at time what? I guess at time t. So I'm supposed to take the limit, so v at time t, the limit as h goes to 0 of, let's see here, 10 minus 3 times t plus h, right? Minus parentheses 10 minus 3t divided by h. So parentheses are important for difference quotients. Dropping a parentheses in the subtraction, ignoring how the minus distributes to the subtracted term, is a common source of mistakes in here. So what happens is the 10s cancel, and you've got a minus 3t and a plus 3t. And so all that's left here is actually minus 3h over h, if you do the algebra here. So the limit as h goes to 0 of minus 3. So the answer is minus 3. The velocity for that position function is just minus 3. Yeah, you have to better bring binoculars next time. My apologies. It's just, there's like a glare from the lights in here, isn't there? Yeah, sorry about that. All right. So you can calculate velocity if you can calculate the limit of the difference quotient, delta x over delta t. All right, let's get back to functions. Let us try a different pattern. I don't think we've done this one yet today. Let us look at, how about something like f of x is, let's see, 1 over maybe 2x plus 7. Let's try that. 1 over 2x plus 7. Let's calculate the slope of that thing at a. So example 8. Here we go. Let f of x equal 1 over 2x plus 7. All right. Let's calculate f prime of a. Here we go. F prime of a is the limit. All right. I'll let you guys, you pick. What? It's random. The limit. So you guys want x or h? H. All right, fine. H it is. H goes to 0 of, all right, so we've got h down here, and we've got 1 over 2 times a plus h plus 7, right, minus 1 over 2a plus 7. Now the first thing I do when I've got one of these ugly compound fractions is I trade it for something ever so much more pleasant to write, which is multiplication by 1 over h. So I've got 1 over h times, 1 over, let's see here, 2, let me multiply that out a bit. That's, well, yeah, I guess, choices. Fine, I'll multiply it out. 2a plus 2h. I'm not sure this is actually a good idea. I'm a little bit wishy-washy on doing that, but I did it, so there it is. 1 over 2a plus 7. All right. Now, what kind of limit are we up against? Well, we've got, infinity. What we got? Well, division by 0 here, and this is what happens here. This goes to what? That goes to 0, right? As h goes to 0, because these become the same. So this is going to 0. So like 0 over 0 is the type again. What should we do? Let's think. Combine fractions, right? I like it. Let us make a common denominator. And so here, there's really nothing common, so we're just going to multiply the denominators. Basically, the cross multiplication trick. So we got here is a 2a plus 7 minus, parentheses are really important, 2a plus 2h plus 7, like that, divided by 2a plus 2h plus 7 times, parentheses, 2a plus 7. All right. Anything reduce upstairs? Yes, lots of stuff, right? So this 2a cancels that 2a, and this 7 cancels with that 7. So all we're left with is that minus 2h, right? But notice that that minus 2h, there's one here, right? And there's one there as well. So making this reduction, this simplifies to limit as h goes to 0 of, there's a minus times a 2, so I got a minus 2 upstairs. And downstairs I've still got that pesky 2a plus 2h plus 7 times 2a plus 7. All right? So then what? Oh, we're done. So we just need to plug it in. See, because at this point, this is no longer indeterminate. By doing the algebra, we've reduced the indeterminacy, and so we can work it out. This is minus 2 over 2a plus 7 times 2a plus 7. In other words, the answer is minus 2 divided by 2a plus 7 quantity squared. Did you guys get it? Now, there is some fine print on that example. What could a not be equal to? Zero's fine. What's that?
The whole quantity can't be equal to 0.
Well, that's true also, but what can a not be? Negative 3.5. Yes. So minus 7 over 2. Right. Yeah. Because that would give us division by 0 here. But you know what? It would also give us division by 0 in the original formula as well. So this is kind of typical. If you got a vertical asymptote for your function, it will also be a vertical asymptote for the derivative of the function. But I'm talking about the derivative as a function, which is something I'm supposed to do tomorrow. So one last example. I'm going to use the x formalism for this one. Suppose we had f of x 1 over x squared. How would that go? F prime of a, limit as x goes to a of 1 over x squared minus 1 over a squared divided by x minus a. But that is the limit as x goes to a of 1 over x minus a times parentheses 1 over x squared minus 1 over a squared. I just like that step to make things prettier, personally. Didn't really do anything, just reformatted it. Then what? Same thing we did in the last example, right? Make a common denominator. And this time we're going to get ourselves an a squared minus x squared over x squared a squared. And how does a squared minus x squared factor? Does it factor? Surely it does, right? So we've got the limit as x goes to a of minus x plus a times x minus a divided by x minus a times x squared a squared. Now what I did there, guys, is I just made my life a little bit easier because you see I've got this a squared minus x squared, right? It's easier to look at that as minus parentheses x squared minus a squared, at which point I can easily see that's x plus a times x minus a, right? So I use that idea to factor this to that, just to make things easier to see. And of course what happens is you've got, yep.
Where does the minus sign in front of x plus a come from?
Right here. So I was just explaining. So then that right here, those cancel. And once those cancel, we can plug in a, and there you go. Minus a plus a over a squared times a squared. Answer is minus 2a over a to the fourth, or if you like, minus 2 over a cubed. I think for this one, maybe the x formalism is easier. I don't know. This one might have been easier too if I'd used the x formalism. I don't know. I go back and forth. So does that make sense? Well, yeah. I don't like minuses, so I pull them out to make the factoring more natural. So tomorrow we will talk about how the derivative can be put together and pointwise define itself a new function based on the old function. So that's tomorrow. Thanks, guys.